Yeah, hello everyone. So this is a question from JEE Mains 2026 28 Jan evening, and you can pause your screen and go through the question. So the question is giving us two statements. The first statement is increasing order of boiling point of hydrogen halides. So they're asking us to arrange the hydrogen halides in terms of their boiling point. Okay. The second statement is the increasing order of melting point of hydrogen halides is, so they have given us a statement. In the light of the above statements, choose correct answer. So the options are basically asking us which statement is true, which statement is false. So we have to say that which one is true, which one is false. Okay. So the chapters involved are chemical bonding, gaseous state, P block from 12th standard. Okay. So to answer our question, I have some data from NCRT. So I'll be writing the data here. Melting point in Kelvin, boiling point in Kelvin, and the first row is for hydrogen fluoride, second one is for hydrogen chloride, third one is for hydrogen bromide, fourth one is for hydrogen iodide. So for hydrogen fluoride 190, boiling point is 293. HCl it is 159 and 189, 185 and 206, 222 and 238. Okay, so if we look at this data and if we look at this statement, the boiling point order, if you can see, maximum HF, then we have HI 238, then HBr, then HCl. Okay, so this statement one is correct, this is true. And if you look at statement 2, the increasing order of melting point of hydrogen halides, so you can say maximum is of HI, then HF 190, then HF, then HBr 185, then HBr, then HCl last 159. So even statement 2 is true. Okay, so now we need to understand why is this the order, or why is this the pattern. Okay, so first I want to talk about statement 1, which focuses on the boiling points. So the boiling points are the temperature at which a liquid converts into a gas. So it basically tells us the intermolecular strength in the liquid state. Okay, so if we look at all the halides, HF, HCl, HBr, HI, so it is quite understood that this guy has the highest boiling point. There is no doubt about it, because this guy can show hydrogen bonding, these guys cannot. They cannot show hydrogen bonding. Okay, for a molecule to show hydrogen bonding, there are two criteria. Okay, the first criteria is the molecule should contain a highly electronegative atom linked to hydrogen atom. Okay, should contain a highly electronegative atom linked to a hydrogen atom. And the second requirement is that the size of the electronegative atom, okay, it should be small. So the electronegative atom should be small. Okay, so therefore only limited guys linked to hydrogen can show hydrogen bonding. So those atoms are fluorine, oxygen and nitrogen. So whenever these guys are present adjacent to hydrogen, then we say that okay, they can show hydrogen bonding. So therefore you can see chlorine, bromine, iodine, they are electronegative, but they are a bit bigger in size, therefore they don't form hydrogen bonding. So therefore it is understood that okay, hydrogen fluoride is having the highest boiling point. There is no doubt about it. And if you look at the order, so hydrogen fluoride has the maximum. Okay, now next, if we observe as we go down from HCl to HI, it increases. Okay, so the reason behind this observation is, so that is HCl to HI, it increases the boiling point. So the reason behind is because the size of the halogen is increasing. Size of halogen increases. Okay, now as the size increases, the attractive intermolecular forces. So there are many other attractive intermolecular forces. Okay, see, hydrogen bonding is one of them. Or so these attractive intermolecular forces are also known as van der Waals forces. So we have, so actually there are, six types of them. One is dipole dipole, another one is, induced, sorry, ion dipole. The third one is ion induced dipole. Then we have dipole induced dipole. Then we have London dispersion forces. Then we have hydrogen bonding. Okay, so these guys, that is dipole dipole, ion induced dipole, London dispersion forces, these are collectively known as your van der Waals forces. Okay, and so and to be specific, as the size increases, okay, so you can see in HCl, HBr, HI, hydrogen bonding doesn't come into the picture. So we have dipole dipole, ion induced dipole, and London dispersion forces. And out of these three, London dispersion forces are very important for us. Okay, and these three are collectively known as the van der Waals attractive forces. Okay, so a very important thing is, as size increases, the attractive intermolecular forces among the molecules increases, or you can say the van der Waals forces increases. So what's going to happen is, for example, HCl molecule, so it will be attracting many HCl molecules through forces, and these forces are your van der Waals forces. And since HI is bigger in size, so it will attract even more HI through attractive van der Waals forces. So therefore, you can see there are more associations in the case of HI. So therefore, to break these bonds, we need to give very high temperatures to HI compared to HCl. That's why it increases from HCl to HI. Okay, so that's the reason why the boiling point is, maximum for HF, because obviously hydrogen bonding dominates over van der Waals. There is no doubt about it. Okay, in the liquid state. And so hydrogen fluoride maximum boiling point, and then it increases from HCl, HBr, HI, because the size increases and the van der Waals forces are increasing. So that's the scene about the hydrogen bonding and in the liquid state, and also about the boiling point. Next, coming to the second statement. So second statement is very important, and it's a bit different, because when you look at the melting point order, HF shows hydrogen bonding even in the solid state. Okay, so we are talking about melting point. Melting point is when solid converts into liquid. So HF shows hydrogen bonding even in the solid state. Okay, that's why it has a high melting point, understandable. And but the maximum value is for HI. Okay, so that is very important. We need to take care of it. So the maximum melting point is for HI, and then for HF, and then for HCl, and then for HI maximum, then HF, then we have HBr, then we have HCl. Okay, so we need to understand why is this the scene. So HF shows hydrogen bonding in the solid state, so that's why it has abnormally high melting point. Okay, but we need to understand why HI's melting point is even more than HF. Okay, so the reason is because it has very high molecular mass. So its molecular mass is high, and the London dispersive forces, or you can say the van der Waals forces, so they kind of outweigh the hydrogen bonding. Okay, so they kind of outweigh the hydrogen bonding. So you might be asking me, why is this not the scene in boiling point? Because boiling point, it's in the liquid state, and in liquid state the hydrogen bonding dominates, but in the solid state the hydrogen bonding in HF in the solid state, they form specific chains, but they are not able to create a high melting solid lattice compared to the dense packing of heavy and highly polarizable HI molecules. Okay, so we need to understand in the solid state, the hydrogen bonding is not that effective in building a very high MP lattice compared to HI. Okay, because in HI it shows only van der Waals forces, but because of the van der Waals forces, it creates a solid, it creates a lattice whose the packing is very dense. Because of that, um, the melting point is very high in the case of HI. Okay, so the point in a nutshell is that in liquid state hydrogen bonding dominates. That's why HF has the highest boiling point compared to HI. In the solid state there is hydrogen bonding in HF, but it is not able to dominate and create a lattice. It forms specific chains, but it cannot create a lattice having very high melting point. But HI, having van der Waals, weak van der Waals forces, it forms dense packing. More number of molecules are associated with it to form a very dense packed structure. In HF you can have maximum this kind of structure, but if you follow the hydrogen bonding scheme in the solid state, so you can see it's not a very good packing, which will result in which therefore doesn't result in a very high melting point. But in the case of HI, it doesn't show hydrogen bonding, yes, but it does show van der Waals forces, so the molecules can come and get attached, and hence it results in a very dense packed solid lattice, and hence it has the highest boiling point. Okay, thank you.